In this video, we're going to go over how to extract information for both the x of t and y of t functions from this curve. So remember, this is a parametric curve, so we're thinking about the x component and y component separately, and they're both functions of this parameter t, which we can think about as time. So let's just kind of think about this orientation of this spiral we see down below. So I've just outlined a couple t values for us right now. So let's just see when t equals 0, we're starting here, and then we're sort of moving in this counterclockwise sense around this spiral as t increases. So an important thing for us to recognize here is this parameter t dictates the orientation along this curve, or in other words, how we move around this curve in general. So it describes a particular direction. So as t changes, as t increases, that's going to dictate the direction around this curve. And we just have a couple points outlined. So when t equals 1, we're there. When t equals 2, we're there. 3 there, 4 there, and so on and so forth. So we're just given a couple t values and things like that around the curve. So what are we going to try and do here? Well, we're going to try and extract or sketch the plots of the x of t function and y of t function that could create this type of spiral. So the way I want to think about doing this is point by point. So we're going to really think about this in a very kind of iterative type of sense in which we think about the first point, how we get to the next point, how we get to the point after that, the point after that, and so on and so forth. So we're going to think about this also for one coordinate at a time. So let's think about this first in terms of x. So when I make this sketch of x versus t, now I want us to draw attention to, I am putting our x as that dependent function on the vertical axis, and t, our parameter, is now on that horizontal axis as the independent variable. And so in this example, I have t outlined from t equals 1 all the way to t equals 6. So I'm just going to mark those types of things down, or t equals 0, I should say. So t equals 0, we're basically, t equals 0 there, then 1, 2, 3, 4, 4, 5, and 6. And let me actually just shrink this up for a moment, just so this fits all better on one page. All right, so again, we're going to do this point by point. So let's start off at that first point. So starting off at that first point, when t equals 0, we notice where are we in terms of the x-axis? So in terms of the x-axis, since we're on the right-hand side of that y vertical axis, our x values are positive at t equals 0. So in general, let's just start off at that positive x value, some positive x value. Again, we're just trying to get a sense of this sketch of this function. So we're done when t equals 0. What happens when t equals 1? Well, when t equals 1, we move generally to the right. So again, if we're looking in what's happening in terms of x, we're really only turning our heads left and right. So between t equals 0 and t equals 1, we're moving towards the right, which means that our x value is growing since we're moving towards the right. So between t equals 0 and t equals 1, our x value increases some amount. And for these sketches, we don't really know what happens in between, or we don't concern ourselves about what happens in between t equals 0, t equals 1. We're just trying to get a sense of what this function looks like a bit. All right, let's think about what happens between t equals 1 and t equals 2. Well, compared to t equals 1 and t equals 2, our x value looks approximately the same. We're not really moving left or right if we're just looking at what's happening right at t equals 1 and t equals 2. I guess if you have a really good eye, you'll notice, well, we are kind of shifting over to the right a little bit and then coming back to the left a little bit between t equals 1 and t equals 2. But in general, we're basically ending up at the same x value. So between t equals 1 and t equals 2, well, we could say maybe we move to the right a little bit, then come back to the left. So if we're ending up at the same x value, maybe we do increase and then just come back and decrease a little bit. All right, let's see what happens between t equals 2 and t equals 3. Well, between t equals 2, we are farther right than when we are at t equals 3. So because we're moving to the left, our x value is decreasing. And it's actually decreasing until about the x value in which we started with at t equals 0. So what that means is at t equals 3, we're basically ending at the same x value that when we started with. Again, x is the dependent variable here, so we're ending at that same x value. And we're moving to the left, so we're kind of going down. So that's what's happening between t equals 0 and t equals 3 so far on our curve for the x component of our spiral. All right, what's happening now between t equals 3 and t equals 4? Well, between t equals 3 and t equals 4, the x value is going from a positive x value to a negative x value. In general, x value is still decreasing because we're moving to the left in the xy plane. Again, focusing on just what's happening in terms of the x value. And so we're moving horizontally left, which means our x value is decreasing. So between t equals 3 and t equals 4, we're moving to the left, which means our x value is going down, but also where we are in terms of the xy plane, we are now on the left-hand side of that y-axis. So our x value is negative. So we're actually dipping down at t equals 4 into negative values of x. So in terms of our x versus t plot, our x value is negative. We are below that horizontal axis now of t. All right, but what happens now at t equals 5? Well, from t equals 4 to t equals 5, in terms of x, our x value is increasing because we're going from a lower x value and moving to the right to a higher x value. Again, only looking what's happening horizontally here. So t equals 4 to t equals 5, our x value is increasing. So in this bottom plot down below, we are moving up in terms of x versus t. So, and where we're actually ending is just about the same x value in which we started with. So our x value is going positive again, and we're increasing to about that x value we started with. All right, what happens between t equals 5 and t equals 6? Well, if we're looking strictly in terms of the x, we are moving to the right because we're starting at a lower x value, and the x value we are ending at is further right on that x axis. So our x value is increasing. And where are we increasing? We're actually greater than any x value we've seen before, since we're farther right than any value we've seen before. So we could kind of just put this maybe up above. So between t equals 0 and t equals 6, this is kind of a sketch of maybe what our function x of t is doing. All right, let's do the same thing now, but let's do it for the y coordinate. So I'm going to grab our sketch and bring it down below. All right, let me just clean this up really quickly. All right, so now we're going to be looking at sketching the y of t versus t. Which means we're going to make our axes, in this case, the vertical axis is y of t, and the horizontal axis is t. And again, we're really only looking for values between t equals 0 and say t equals 6 in this case. So let's think about what happens in terms of the y function. So remember, now that we're starting at t equals 0, basically what we're going to think about is how do we move vertically? What we care about for y is vertical motion now. Are we moving up or down between these successive points? So between t equals 0, we notice that, well, since our t equals 0 is above the x-axis, we're starting off at a positive y value. So just, I guess, in general, we can put that somewhere here. What's happening between t equals 0 and t equals 1? So t equals 1 is there. As we move to t equals 1, well, those y values look just about the same. We're not really moving up or down anywhere. So because of that, our y value basically stays the same between t equals 0 and t equals 1. Well, what's happening between t equals 1 and t equals 2? Well, between t equals 1 and t equals 2, we are moving upwards, which literally means we're starting off at a lower y value, we're ending at a higher y value. So on our y versus t plot down below, our y value would increase. Again, we're just trying to sketch this so we know our value increases some between t equals 0 and t equals 1 and t equals 2. Well, what happens between t equals 3 or t equals 2 and t equals 3? We're moving even higher. We're starting off at t equals 2 at some y value, and we're moving to a higher y value just slightly. All right, so between t equals 2 to t equals 3, our y value is still increasing, but maybe just a little bit, but it's still increasing some. All right, what's happening between t equals 3 and t equals 4? Again, looking at the y coordinates, we're just considering with, are we moving up or are we moving down? So between t equals 3, we're starting off up above. T equals 4, we're ending at a lower y position, so we're moving down. The other thing to note here, though, even though we're moving down, we're still above the x-axis, so our y value is still positive here. So we're actually real close to the y value that we started with. So at t equals 4, we're basically ending up at the y value that we started with, something like this. All right, then between t equals 4 and t equals 5, in terms of our motion, we're starting off at a higher y value at t equals 4, and we're ending at a lower y value at t equals 5. So our y value is decreasing. Another thing we can notice is we are getting really close to that x-axis here, which means our y value, well, it's still positive because it's above that x-axis, but it's really close. So what we could really represent here then down below is at t equals 4 to t equals 5, our y value is close to 0. We are moving down because we're starting again at t equals 4 at a higher y value. Then we're ending at t equals 5 at a lower vertical position, but we're close to y equals 0. So we can also show that on this sketch. And then between t equals 5 and t equals 6, well, our y value is increasing. T equals 5 is positive, but close to that x-axis. T equals 6, we are growing higher. And we're actually growing just about to the same height that we started with. So that's how we can decouple or extract information about x of t and y of t from a parametric curve that we just see sitting there in the plane, like this spiral. We can break this curve into points and then keep asking ourselves, what's happening between those points? If we're asking about the x of t, we're wondering, are we moving right or left in terms of the horizontal movement? If we're asking about y of t, we're asking, are we moving up or down in terms of the vertical motion for the y of t?